Okay. Hi everyone. Thank you for joining us today. I am Nikoo Mashayekh, and along with my teammate Jungjoon Park, we are going to present our work. Our project titled "Critical Evaluation of Prompt Strategies in Emotion Recognition." Emotion recognition. We have worked under our mentor, Dr. Arasu Narayan, as part of the Sentimental group within Normatch ISP program. First, I want to start with the introduction of our work. Emotion recognition is one of the key components in affective computing, and it's becoming increasingly important in various fields such as mental health, customer service, and human-computer interactions, making them more responsive to human feelings and improving their interaction with their users, such as social robots. For this project, we are using large language models as short-term LLMs. These machine learning models are trained on huge dataset, enabling them to understand and generate natural language. One of the advantages that these models have is that they can perform tasks with minimal or zero examples. And in our project, one of the things that we are comparing that is mentioned also in our project title is how commercial models like GPT perform compared to open source model in recognizing emotions in text from text. There are also two important techniques that we use in our project and our study. One of them is prompt engineering, and the other one is retrieval augmented generation, in short-term RAG. Prompt engineering is basically designing inputs to guide LLM's output. By optimizing these prompts, we can control models' behavior, enhance output quality, and reduce the risk of generating inaccurate or misleading information. And RAG helps the LLMs by retrieving relevant context from external resources before generating an output. As you can see in the picture, they find they retrieve documents, for examples, from other resources. Our project aimed to classify emotions through prompt engineering strategies by evaluating commercial and open source LLMs. To achieve our goal, we focus on two main key research questions. One of them is how models size contribute to the performance differences between commercial and open source LLMs. And second one is that how is the performance of models when distinguished between the specific emotions such as shame and guilt in the models. Now let's move on to the materials and method section. In our methodology, we divided our work into 5 main stages, starting from data pre-processing, followed by designing various prompt strategies, selecting suitable model for our work, and defining evaluation metric, and finally performing through results analysis. For a study, we use easier dataset. This dataset includes around 70,000 emotional events globally, and it provides annotation for 7 distinct emotions. As you can see in this table, these emotions are anger, disgust, fear, guilt, joy, sadness, and shame. Before using the dataset, we have to work on the pre-processing. And for pre-processing, first we skip man-informed data points that we have in our data, and next we remove any duplicate samples that we had in the dataset, and finally we excluded entries that were too vague or unclear phrases. For example, no responses, cannot remember, and never experienced from our dataset. Our project heavily focused on prompt engineering, and in this slide I want to talk about prompt components that we use for our prompt structures. The first one is the necessary part. This includes the basic instruction and specifies how models should structure their responses. For example, we stated that the model should classify, for example, these 7 emotions, and the responses that we wanted should be in the JSON format, including confidence score and expressions of the results. Secondly is the persona. In persona, we guided the model to adopt a specific role or expertise, such as you are an expert in the emotion analysis for a model. And in definition component, we want to provide a clear definition of each emotions, helping model to distinguish between similar emotions. As you can see in this part, for example, for joy, we define the joy as happiness, pleasure, and delight. And for the last component in context, we especially for the few shot strategies, we bring example for our models to help them to understand the context better and improve the classification accuracy. For example, we give the model text, for example, in here, getting accepted to the university to understand the emotion joy better. To use based on the prompt structure components, we also design 5 main strategies. One of them is no persona, which only has instruction and output. Baseline persona is the instruction in this. The instruction in these strategies has a role to them. For example, you are an expert in emotion analysis. Zero-shot strategies is similar to the baseline persona, but combined with the definitions for the emotion. And fourth one, future strategies. The instructions is combined with persona definition and specific examples for the models to understand the context. And lastly, RAG strategy is similar to the future strategy, but instead of predefined examples, it find a similar text example to provide a better accuracy for the model. To evaluate the prompt strategies, we tested several open source and commercial models, which is brought in this table, as you can see. Primarily, we experimented with Llama version 3.1 and Mistral in an initial experimental phase. And additionally, we experimented with Gemma version 3 and Quen version 2.5 due to the diverse model sizes that we have. They have, for example, for our study, we use version model sizes 1.5 billion, 7 billion, and 40 billion parameters for Quant version 2.5, and model sizes 1 billion, 4 billion, 12 billion parameters for Gemma 3. Lastly, we also compared these open source models with commercial ones such as Cloud 3.5 Sonnet and GPT-4, which typically show lower prompt sensitivity due to the architecture that they have other than their open source models. The next one is the result that I will send it to my teammate, June.
Do you hear my voice?
Yes.
Yeah. So, thanks. So, yeah, I'll keep going. So we conducted an experiment evaluating how various prompting strategies affect emotion recognition performances across 3 open source LLMs like Llama 3.1, QN, and Mistral. It's approximately 7 billion parameters in size. So performance metrics, precision and recall and F1 score were calculated using macro averages and visualized as blue group bar graph here. And from the left, baseline and zero shot and few shot from conditions. So here, the red dotted line here indicates accurate some accuracy baseline of approximately 60% to highlight some difference between the metric widget. So as we illustrated in the graph, our models consistently demonstrated some improvement in overall metrics, especially for F1 score, as the prompt strategy were progressively enhanced, like from zero shot to few shot, or some baseline to zero shot to few shot, and etc. So we further diversified our prompt strategies. So on the far left, the newly added blue area labeled no persona from condition. So in here, we just remove the persona instructions such as you are an emotion recognition expert from our baseline prompt. So information is removed. And conversely, on the far right, the purple area labeled for the RAG experiment. So in this setting, we retrieved the top 7 dataset texts, which is most similar in Euclidean distance to the given input text. So it effectively providing some dynamic few-shot examples of putative similar emotion. So consequently, these newly added 2 strategies demonstrate the lowest and the highest performance across all of the model and illustrates the impact of the different prompt strategy in the some fixed model size of about 7 to 8 billion. So given these findings, we investigated whether the model size impacts the effectiveness of prompting strategies because so far we just used some 7 billion models. So we expanded our experiments to include two open source LLMs, Gemma 3 and QN 2.5, testing each across three different model sizes like from 1 billion, 4 billion to 12 billion or something. So we observed a consistent trend across all models. As the model size increased, the relative improvements gained from prompting strategies diminished. As you see in this more than 10 billion case, there's subtle differences. Actually, there's a little bit slight increase were observed, but when you compare to the 1 billion or 4 billion or 7 billion cases, the increment is more diminished. So this diminished impact of prompting strategies was particularly pronounced in experiments with commercial LLMs such as GPT and Cloud. As you know, it is really big, large model. So as shown in our results, some differences in performance due to varied prompting strategies were minimal for those large commercial models. Nevertheless, we consistently observed the improvement when the additional informative context, such as some few shot examples or RAG, was used for the text by emotional recognition. And next, we examine the detailed prediction result for each emotion labels, not just all of the macro average stuff. So the data set classifies data into 7 distinct emotion categories. And as you see this confusion matrix and this blue group bar graph here. So each label, each x-axis means emotion labels such as joy, fear, anger, sadness, disgust, shame, and guilt. So same here, joy to the guilt. So interestingly, each emotion seems to exhibit some unique prediction patterns, such as so in the left part, most of the emotions show some higher accuracy, and the right part, for example, disgust and shame and guilt, their accuracy was not that high. For example, about 60% and 70%. So this group bar graph also correspond the same results. And also we calculated some unknown ratio. It is so in when we use LLM to uh, for the emotion recognition, sometimes LLM fail to respond some specific categories of the emotion. So this unknown ratio means the failure cases. So in here, so so higher unknown ratio was observed in some emotion classes such as shame and guilt, and this kind of trends were observed across all experimental conditions like shame and guilt. Emotion class show more lower level of accuracy and a little bit higher level of some unknown prediction failure cases. And so our high performing models were GPT and Cloud Sonnet models, so commercial models with RAG prompt strategy. And when we looking deeper into the class specific performances, we found some intriguing differences. So Cloud performed best for the sadness and guilt and average F1, whereas GPT outperformed Cloud for other some emotions a little bit. So this led us to consider combining the strengths of these two top performing models. So to explore this, we conducted some ensemble experiments that combined prediction from both models along with additional synthesis guideline prompts. So for this ensemble test, we utilized two open source models like QN 2.5 14 billion and Gemma 3 12 billion. So as you see here, as a result, both models actually exhibited significant improvements exceeding plus 6% with QN 2.5 and also finally QN 2.5 14 billion achieving the highest F1 score of 78.4 accuracy. So in conclusion, our experiments demonstrate that the effective prompt strategies notably improve some emotion recognition performance. We also observed that the effectiveness of prompt strategies not always same, but diminishes with an increasing model size. And also notably, there is some class-specific performance variations. And finally, there's some ensemble methods deliver the highest overall performance using some GPD model and cloud model. So their mixture of their models result. So final Q2.5 model could improve more than the 6% of the accuracy. So our study faced several limitations, such as some resource constraints or some modality limitations and also some categorical classification limitations. So based on these limitations, now we are working on some further studies, such as expanding various data sets and fine-tuning and also class-specific differences. And in the near future, we have more plans such as integrating multimodal data and categorical dimensional mapping model to expand our research. So this concludes our presentation. Thank you very much for your attention.